Hello and joiner baddies, welcome back to another video. Today's first question is, Larry writes a list of numbers that has average 14, median 21, and mode 11. Mo created a list by adding 12 to each number in Larry's list. What are the average, median, and mode of Mo's list? So let's tackle the easier ones first so that I don't have to explain them afterwards and make them look really, really stupid. Alright, median. First of all, since Mo added 12 to each number in Larry's list, the number of terms does not change, nor does the order of the numbers via the list. Therefore, the middle number will still be the middle number, albeit since it's been added 12 to, it's going to be equivalent to 21 plus 12, which is literally just 33. The order of the numbers does not change, the median does not change, besides increasing by 12. But so does everything else, therefore it does not move up or down. And the mode being 11, this is the same thing. The number that is the most of is still going to be the most of. We're just going to add 12 to it. Therefore, it's 23. But the average is slightly different and may need a little bit of proving. Let's call the number of numbers in our list n. So 14. The average is 14, therefore the sum of all the numbers should be 14n. But since we added 12 to each number in Larry's list, this is basically adding 12n divided by n. If we simplify, we'll just get 14 plus 12. Therefore, the average works the same as the other two terms, which is basically equivalent to 26. I don't know why I wrote that. That's not a 6. Alright, that is a 6. Moving on to B. Curly creates a list by multiplying each number in Larry's list by 2. What are the average, median, and mode of Curly's list? This works the same as problem number A here. Since the average, median, and mode, the median and the mode do not change, they stay the same. The numbers do not have anything new added to them, therefore they are still the same. So since, what was Larry's? Alright, so since Larry's list was average 14, median 21, and mode 11, so 21 multiplied by 2, 42, 11 multiplied by 2, which is 22. The average proof goes the same way, since it's just multiplied by 2 of 14n divided by n. Basically get 28n divided by simplifying the n, we'll just get 28. And so this list also works the same as the one above that I just showed. Moving on to actual problem number 2 with also ABCD. Just ABCD. Each of these 9 friends chooses their favorite positive integer. The median of the chosen numbers is 91. What is the smallest the average of the 9 chosen numbers could be? First of all, if the median of the chosen numbers is 91, it doesn't say anything about the average, the mode. We just need, that is not 9. Okay, 1, 2, 3, 4, 5, 6. Let me just 1, 2, 3, 4, 5, 6, 7, 8, 9. And the smallest the average of the 9 chosen numbers could be. Since it never said that the numbers were different, we can set the numbers above our median as just 91. Like I said, they never said it could not be the same as the median, therefore, the smallest we can go, since it has to be greater than the 91 or equivalent to, in this case, we're just going to set them all as 91. And to make the smallest of the average of the 9 numbers as possible, we're going to set all the other numbers as 1. Since this is basically now just 4 plus 91 multiplied by 5, so 91 times 5. 90 times 5, which is 450. 450 plus 5, which is 1 times 5, so 455 plus 4, which is 459. And we gotta go 459 divided by 9 now, which is basically 51. So the smallest average of the 9 chosen numbers is 51. Moving on to problem number B. The median of the chosen numbers is 91. Is there a limit to how large the average of the chosen numbers can be? If so, what is the largest the average can be? There is no limit here, because as you guys know, there is an infinite amount of numbers. Even if we went like a Googleplex amount of zeros to like a 9, there's still a plus 1, which means that since we can set the median as 91, everything above the median could literally be as big as you possibly want it to be. Therefore, there is no limit to how big the average can be. there's basically always a +1. There is no limit, that it's infinite. There's no possible limit. Yeah, I got my point through, hopefully. C, the average of the chosen numbers is 91. This time it has changed to average. Do not forget that. What is the smallest the median of the 9 chosen numbers could be? Okay, so this problem, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to add a gap in between these two, or else they look like one thing. So we don't actually know the median in this case. However, it has told us that the average of the chosen numbers is 91. So if we set our median to the smallest positive integer we possibly can get, 1, set everything before that to 1 as well, this basically leaves, since in the entirety of our 9 numbers, the sum added together has to be equivalent to 91 multiplied by 9, each of these 5 ones are each missing a 90. Which means that we basically just need to add it back on into the last bit. One of them are just going to have to take the bunt of 2 90s, aka 180. However, it's not really asking what the other numbers are. We do not necessarily need to know this. It's just 91 plus 90, 91 plus 90, 91 plus 90, and a 91 plus 180 because there's an extra one and there's only 4 spaces. But yeah, the smallest median of the 9 chosen numbers could be, it is 1. And the last number, the average of the chosen numbers, is 91. What is the largest the median of the chosen numbers could be? Okay, so here, since we do have a finite number this time, since it's the average has to be 91, the median can't be like infinity. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And since the average of the chosen numbers is 91, we can go about it the same way as last time. To make the other numbers above this number the greatest as possible, just like in the first problem, we're going to set these 5 numbers to be the same. And we're going to set the first 4 numbers as just 1 to maximize the output, quote unquote, of the other 5 numbers. And since these guys are each missing a 90, just like usual, 4 times 90, which is 360, which we can split within the 5 numbers. So we just go 360 divided by 5, which is then equivalent to 735, 102. So 72 for each number. 91 plus 72, so 91 plus 72. Since all 5 of these numbers are equivalent, so the number they receive from the ones is also equivalent, so 316. So 163 is the largest the median of the chosen numbers could be. 163. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye. Just really zoom out here.